Having a lot of choices sometimes makes it difficult to make a choice. And in the world of multipathing, where the ESXi host has multiple choices for sending I/O traffic between itself and storage, I wanted to chat with you in this nugget about some of the plugins that are used as part of vSphere to help make those connectivity path choices between the ESXi host and the storage appliance. I'd like you to imagine that you and I are making a proposal to our management to get additional storage that we can use with our vSphere environment. And one of the questions that comes up is regarding the number of LUNs that we want to add. So in the case of our network-based iSCSI, what are the pros and cons of having a few large LUNs versus many smaller LUNs? So let's take a moment and just compare and contrast that. So regarding the benefit of having a smaller number of larger LUNs, some of the benefits would be things like more flexibility as we create virtual machines without asking the storage administrator for additional space, because the LUNs and the respective data stores are bigger to begin with. We'd also have more flexibility in resizing a VM's disk, for example, and growing a VM's disk, because we have more space. That also allow more space for snapshots or other storage needs that we have if we had larger LUNs to begin with. And also another benefit of a few larger LUNs is that we'd have less data stores that we need to manage. Because managing 4 data stores that are large might be a lot easier than managing 20 data stores that are smaller, simply because of the quantity. Now, regarding the other side of using many smaller LUNs compared to a few larger LUNs, there are some benefits here as well. And the benefits for many smaller LUNs is we're going to have less wasted storage space. Because we have smaller LUNs, we could categorize that storage on a more granular basis. For example, on some of those LUNs, we might implement RAID for fault tolerance, while other LUNs we could set up without fault tolerance based on the needs of the VMs that are going to be using that storage. Also, with many smaller LUNs, we have more granularity with things like disk shares and multipathing policies to a specific LUN. And also with multiple smaller LUNs, we're going to have better performance. And that's because there's going to be less contention on average for a single LUN compared to if we had just a few larger LUNs that everyone was using. Another aspect that we'd want to consider are the capabilities of that storage. Because if we have certain VMs that have certain requirements regarding storage, we want to be able to match up the VMs that need that type of service with the data stores that provide that level of service. And one of the questions that's likely to come up is, how do we know, for example, if we have a VM that needs certain levels of capabilities in storage, how do we know which data stores have those capabilities? And there's 2 basic ways. Number one, we've done in a previous nugget, and that is to do tagging. So by administratively tagging data stores with certain capabilities, when we're associating a VM with the data store, we can search and assign the appropriate data store type based on the tagging we've previously done on those data stores. Another option that we can use to identify capabilities regarding storage is to leverage VASA, which stands for vSphere APIs for Storage Awareness. So if we have a storage provider that's compliant and uses that feature, using VASA, it can announce capabilities, the health, configuration, and other events regarding that storage. Another aspect regarding making sure our ESXi host has access to storage is to provide some fault tolerance. And we can do that with multipath. So as we've gone through our nuggets together, we've implemented multipath. We have 2 uplinks going from the ESXi host. And because we used on the ESXi host software-based iSCSI initiators, we had to configure some VM kernel networking that we bound to the host bus adapter for the iSCSI initiator to make it work. Now, if we weren't using software-based iSCSI, we could use hardware. We could have a hardware solution, and there's 2 types. There's dependent, and there's independent. And with dependent, we have a hardware-based solution for our iSCSI initiator, but we still have to configure some VM kernel networking to go ahead and support it. And that's why it's referred to as dependent hardware. On the other hand, if we have independent hardware, it's configured with its own IP connectivity and everything else to go ahead and access the iSCSI target and doesn't need any VM kernel networking to be done in conjunction with an independent hardware solution for iSCSI. So these guys right here depend on the VM kernel networking, and the independent hardware solution does not. And going back to multipath, ideally we'd have a couple of separate paths coming from the ESXi host and also a couple of different paths available at the iSCSI target. Now in our lab environment, we have a single IP address for a single target. And as a result, if that IP address goes away or that path goes away, we're going to lose connectivity to our storage. And that's why in a production environment, we'd have our storage processor with at least 2 interfaces and 2 IP addresses that we can connect to. And that way we're protecting against a path failure from the ESXi host perspective. We're also protecting against a single interface failure at the storage processor for our network-based storage. Now, regarding having multipath support between our ESXi host and storage, a question comes up, which path should we use? Should we use just this path and have this path as a backup, or should we use both? And in either case, the idea is that we have some fault tolerance built in to tolerate a single failure. And to help make the decisions regarding which path should be used, VMware implements a pluggable storage architecture, which is flexible, meaning a third-party vendor could write their own modules to plug in that would work in perfect harmony with their storage provider solution that they're selling. And out of the box, VMware has a native multipathing plugin. It's called NNP. That's the acronym for short. And as part of the VMware native multipathing plugin, there are two categories, if you will, of sub-plugins. One is SATP and the other is PSP. The SATP is an acronym for the Storage Array Type plugin. And the SATP is responsible for storage array specific operations. And if the storage that you purchase is on the hardware compatibility list, it's extremely likely that the VMware supplied storage array type plugin will be able to handle and address the array specific operations with your storage appliance. And the good news is we don't have to use the built-in one from VMware. So if we're a storage vendor and we're creating our own storage appliance, we could write our own storage array type plugin that works with the NNP to handle those array specific operations regarding our storage appliance that we're selling. So by default, we're using the VMware provided one. So the SATP is focused on the storage side, and there's also the PSP, which is also a sub-plugin under the native multipathing plugin. And the PSP stands for the Path Selection plugin. I've also seen that spoken as the Path Selection Policy. Either way, the acronym remains the same. And the PSP is responsible for choosing a specific path from the ESXi host as it goes to the storage. And if we're using a third-party solution, and that third-party vendor has written their own path selection plugin that works with their storage, we could use that one instead. But by default, we have a VMware PSP. And regarding the path selection plugin from VMware, there are three basic options. Number one is use the most recently used path. So in our multipath environment here from the ESXi host to storage, if we're currently using this path for our last I/O, we'll use this path again, assuming it's active for our next request. So you can kind of think of most recently used as a habit. You know how people have habits, they do the same thing over and over again. That's the logic that MRU is using, most recently used path. Another option that we have is fixed. And with fixed, it's going to use the preferred path. So let's imagine that on this ESXi host, this path number one through switch number one is the preferred path, and that's what it's going to use until there's a fault or a failure with that path, and then it can swap over to the alternate path. And if we've set up multipathing and we haven't specified a preferred path, it'll go ahead and use the first path at boot up that has available to it, and it will go ahead and identify that as the quote-unquote preferred path and just continue to use that until there's a problem with that path. And the third option is RR, which is an acronym for round robin. And with round robin, you can kind of think of that as being more fair regarding the paths, because the host is going to use an automatic path selection algorithm that's going to rotate through all of the active paths when connecting to a storage array that is acting as active-passive. Or if the array is active-active, and we're using round robin, it would be considered to be using all of its available paths. And regardless of the storage array, whether it's active-passive or active-active, the round robin boils down to the fact that we're using all of our paths in somewhat of an equal fashion for I/O between the ESXi host and the storage appliance. And regarding the defaults of which of these three options are used, if we have an active-passive storage array, the default for most of those types of storage arrays is going to be MRU. That's the default. For active-active storage arrays, the default path selection policy is going to be using fixed. So those are the defaults. However, we could set up round robin manually. Or if we're using a third-party path selection plugin that's coordinating the efforts between the ESXi host and the storage appliance, they could specify whatever they chose to in their own path selection plugin. And I guess I should point out that the other option that we also have available would be to not use VMware's native multipath plugin at all, and we could simply use a third-party one. And then with that third-party multipathing plugin, they would also be calling on their own SATP and their own PSP regarding the storage array and the path selection policy from the ESXi host respectively. And as we take a look at adding more and more paths with multipathing, there are some disadvantages of getting too crazy. For example, having 4 paths from the ESXi host is probably adequate for both fault tolerance and also for throughput if we're using a technique like round robin, where we can actively leverage multiple interfaces at the same time. And even though the maximums are pretty darn high regarding how many paths we could support, if we're using tons and tons of paths to access, for example, a single LUN, and we have multiple LUNs, we might hit our maximum regarding how many paths we're able to have on the ESXi host as a whole. And as a result, we may limit the number of LUNs that we can actually connect to, because we've already hit the maximum number of paths overall on the ESXi host. So here in the hands-on lab, let's do the following. We're logged on to the vSphere web client as administrator at vSphere.local. And if we want to take a look at the multipathing options regarding a data store, there's an easy way to do it. What we'll do is we'll click on the Storage tab here in the Navigator section. And with storage selected, let's go ahead and use iSCSI2 as our guinea pig. So we'll click on iSCSI2 on the left. Currently it's showing us the VMs tab, so these are the VMs that are currently using iSCSI2 as their home. And what we want to do is we want to click on the Configure tab regarding iSCSI-2. So with the Configure tab selected, now below General we have compatibility sets and we have device backing and connectivity and multipathing. And we select that. To see the details regarding that data store, we'd select one of our ESXi hosts that has access to that data store. So we'll click on the row for ESXi-2. And let me scroll this up just a little bit. And down here we have the multipathing details. So if we expand the multipathing policies here by using the arrow to the left of path selection policy, here it's showing us that we're using the fixed option for our path selection policy. And our three options that we could use are MRU, fixed, and round robin. It shows us also here that we're using VMware's storage array type plugin. And specifically, it's using the default type associated with active storage arrays. And that also would explain why it's using fixed, because the fixed option for the path selection is the default for active storage arrays. So the SATP in use is what drove the path selection policy of fixed in this case. And then under paths, it indicates the owner is NMP, which is the native multipathing module from VMware. And if we expand the paths under that section, and then scroll down a little bit more, here it's showing us our two paths, and these are two paths going to LUN number 2. And currently it has a little asterisk in the preferred column for this one right here. It also indicates status of active I/O. Now, because we didn't go in and specify a preferred path, this is the one that VMware picked based on selecting a path from the available paths when it first booted up. Another way at looking at our storage and multipathing options is from the ESXi host's perspective. So if we clicked on, for example, right here, we clicked on the link for ESXi-2, that'll take us over to the Hosts and Clusters tab with ESXi2 selected. And with ESXi2 selected itself, if we click on the Configure tab, and then under Storage, if we click on Storage Devices, here it has a list of all our storage devices, including our iSCSI for LUN 0, our iSCSI for LUN 1, and our iSCSI for LUN 2. So if we want to focus on that same LUN, in this case LUN 2, we can highlight this row right here, and then down at the bottom, we'll go ahead and scroll up a little bit so we can see the details. It has the device details. And one of the options regarding device details is the Paths tab right here. So if we click on Paths below Device Details, it's showing us here that we're using the host bus adapter 65, which is our iSCSI initiator, and that we currently have one active I/O path that we're using to go ahead and reach that storage. And we're only using one path because we have a fixed policy. Now, if we wanted to change our policy and not use fixed, we wanted to use, for example, round robin, we could change that as well. So if we go back to our data store, so we'll click on the storage icon right here, and then with iSCSI-2 still selected and still on the Configure tab, with the connectivity and multipathing still selected, let's click on the row for ESXi2. And if we want to edit this policy, all we need to do is simply click on Edit Multipathing over here on the right-hand side. So we'll click on Edit Multipathing. And for the path selection policy, we'll use the drop-down, and instead of using fixed, we'll go ahead and select round robin. So with round robin selected, we'll click on OK. We'll give that a moment to process. And now notice here on the path selection policy, it's now showing round robin. And if we expand the details regarding the paths, so check this out. Now it's showing that both of our paths are active I/O. And if we go back to the ESXi host, we'll go ahead and click on ESXi2 once again here from the list. And with ESXi2 selected, under the Configure tab, under Storage Devices, if we click on LUN 2 again, that same iSCSI target, here it's also reflecting that we're using both of those paths. So one other thing I want to point out is that we made this change regarding the path policy for ESXi2. if we wanted to modify the path policy for the other ESXi hosts regarding this LUN, we need to go ahead and modify that as well. So if we go over to, for example, ESXi3, and under the Configure tab with storage devices selected, if we click on the LUN2 again, you'll notice that it still is using fixed. It's using only one path. So if we wanted all of our ESXi hosts to use round robin instead of fixed, we'd need to make that configuration change for each of our ESXi hosts. Now, the other thing that's really important for you and I is let's verify that it still works, that ESXi2, using round robin with its multipathing for iSCSI, can still work with a VM that's using the iSCSI2 data store as the home for its files. And one easy way to verify that it's working is just to grab a VM. For example, let's go ahead and grab VM5. We'll click on VM5 over here on the left. And currently, VM5 is using the host ESXi2. That's reflected here. And here it's also using one of our two data stores in the data store cluster. And if we wanted to verify exactly which data store with VM5 selected, we could go ahead and click on the Data Stores tab, and it would tell us. Ah, look at that. Okay, so we lucked out. So VM5 is running on ESXi2, which is using round robin to get to the iSCSI2 data store, and VM5 is using that data store. So what we could do is just launch this VM and verify that it still works. Now, in your lab environment, if for some reason VM5 is not running on ESXi2 and is not using iSCSI2, you, my friend, have the ability to go ahead and do a migration of that VM over to that host and over to that data store. So since it's already in the right place, we'll go ahead with VM5 selected. We'll click on the icon to boot that VM and just verify that it's working. Now that our ESXi host number 2 is using the round robin path selection for accessing the iSCSI2 data store. So giving that VM a few moments to boot up, and with it highlighted, let's go ahead and click on the icon right here to open a console to that VM. And there it is. Looks like it booted, but we also should check one other thing. Because we have vSphere DRS running, vSphere DRS could have moved this VM to a different ESXi host. And if we had storage DRS running, if there was a lot of contention involved, storage DRS could have done a storage vMotion to another data store. So just for grins, I'm going to hit F11 to take my browser out of full screen, go back to the vSphere web client, and with VM5 selected, I'm going to click on Summary just to verify that it really is running on ESXi2, which it is. And if we click on Data Stores, that would also allow us to verify the data store being used to host the files for VM5. In this nugget, we've taken a closer look at the pluggable storage architecture within vSphere. And we have three basic elements. We have the multipathing plugin. There's a native one that's supplied by VMware. And then two sub-plugins. One for the storage array type plugin, and the other one for the ESXi host path selection, which is the path selection plugin. And then we reinforced that by going to the interface and verifying what the settings were, changing them, and verify that we still had access for our VMs to the respective data stores. So I invite you, if you haven't already, to practice what we've done in this nugget in the hands-on lab to reinforce the concepts and reinforce your skills. And I'll see you in the next nugget. Meanwhile, I hope this has been informative for you, and I'd like to thank you for viewing.